Hey guys, let's do another work and constant force problem. A lever such as the one shown below can be used to lift objects we might not otherwise be able to lift. Show that the ratio of output force, Fo, to input force, Fi, is related to the lengths Li and Lo from the pivot point by Fo over Fi equals Li over Lo, ignoring friction and the mass of the lever, given that the work output equals the work input. Now, in solving this problem, this is a huge piece of information that's going to help us a lot. Work output equals work input. In fact, we're going to work based off this mathematical expression. So this is the scenario we've got here. We've got a person who's got, here's the pivot point, here's the lever, this is the giant rock or whatever large mass that they're trying to lift. Li is the distance from where the force is applied, which is right here, to the pivot. Lo, the output length, is the distance from the pivot to the center of the object where the force is going to be applied. Okay, so here's our forces. Fi, the input force, is pushed straight down, and the output force ends up going straight up. Okay, so let's again start with what we know. We know that work is equal to force times distance times cosine of theta, where theta is the angle between the force and the displacement, right? Now, in the case of the input force Fi, the displacement is going down. Okay, so because the displacement's in the vertical direction, we usually refer to that as height. So I'll call that height input, okay? Now, this part is going to go up, so we'll call that height output, HO. Now, instead of D, we're going to have either HI or HO. Now, theta is the angle between these and the respective force, right? So the F here is going to be Fi or Fo. Now, take a look at this. What's the angle between Fi and HI? It's 0. And we know that cosine of 0 degrees is equal to 1. So, in fact, we can just ignore this part for this problem. The same thing happens for the output. HO and FO are in the same direction. Cosine of 0 is 1. It disappears. So we can, again, just ignore that part for this question. So that can help us simplify this to the following expressions. The input work can be written as the input force times the input height. And the output work is equal to the output force times the output height. Pretty simple, right? Now, using this expression, the work output equals the work input, we're going to make a mathematical expression from this. Okay, so we're going to say Wi is equal to Wo. Okay, and we've got our expressions right here. So Fi Hi equals Fo Ho. Okay, now I want to make a ratio to make it look like this. Okay, so let's get the Fo over Fi. So I'm going to bring the Fi down here. So Fo over Fi equals Hi over Ho. Okay, so now you're wondering, okay, well, I'm working with lengths in the question, not the heights. So how do we make one thing look like the other? Okay, so this is what I'm going to show you now. We're going to work with geometry here to show us how we can change the heights to the lengths. So look at the lever like this. Okay, imagine this is that lever. Now, there's going to be an input force on it going down, right? Fi. And as a result of that, there's the output force, Fo. Now, Fi is going to go down quite a bit. You see how the pivot is so much further to the right? Therefore, we have to push this part down a lot in order for the right side to go up a little bit. Okay, so here's going to be my Hi, this whole distance. This is the distance through which it goes down. My Ho is going to be a little bit smaller. But nonetheless, there it is. Okay, and if we connect these 2 points, essentially what we have is a triangle. Now, what you remember from geometry is this. These 2 angles are called opposite angles. They're the same. And if you recognize that Z pattern, that'll tell you that these 2 angles are the same and that these 2 angles are the same. So essentially what we've made here are similar triangles. Okay, so by that, because the lengths and the angles are the same, we can say that the lengths are also in proportion. So we can actually state that the ratio of Hi to Ho, you can also create the similar ratio for Li to Lo, right? Because the angles have to work out. So we can make this expression. The ratio of height input to height output is equal to the ratio of the input length over the output length. Okay, so because of that, we can sub that in over here. So then we get Li over Lo equals Fo over Fi, which is what we have originally in the question. Okay, so there you have it, guys. That's it for this video. I hope you enjoyed it. If you do have questions, be sure to leave them in the comments section below. And if you like the video, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me. Stay tuned next time for video 98, Work and Constant Force 3.